thing. Suppose we have a circuit like this and we are asked to calculate the currents in the branches. First thing to do is to choose the direction of currents. Here it's not a problem because the source is positive, so the current will flow this way. So what we do once the currents are chosen, we have to indicate the voltage drops in every resistor. Here the current flows this way, so the drop is this direction because the current flows from the highest to the lowest potential. Here the current flows this way, so the voltage drop in this generator is this way, so the current flows from the highest to the lowest. Here same thing, here the same in this direction, and in these two resistors it's in this direction. Now we have to choose a direction for writing the Kirchhoff's laws. In this note first we can say that the current entering, or the sum of the current entering a node, is equal to the sum of the currents coming out of the node. So first equation we can write that I is equal to I1 plus I2. Second equation, you have to choose clockwise or anti-clockwise in the mesh. We have one mesh here, second mesh here. The third mesh is not needed. We can calculate I3 and I4 without taking this mesh. So this is the direction we have chosen clockwise for writing the Kirchhoff's voltage law. So if the voltage has the same, if the voltage drop or the source voltage have the same direction as the one chosen, so it's plus. For example, here this V has same direction in clockwise, so we write V. If it is opposite, we write minus VR. This one is VR, this one is VR1, minus VR1 is equal to 0. Same thing here, this has same direction, so we write VR1, opposite, minus VR2, opposite, minus VR3, 4, is equal to 0. Now, let's use Ohm's law. Here V is equal to R times I, the drop here, plus R1 times I1. So it means V is 80. So let's write it's 80 is equal to R is 5, 5I plus R1, 60 I1. Second mesh, it's here, so VR1 is R1 times I1. This is the third, minus R2 times I2, and minus, as I said, R3, 4 times I2 is equal to 0, so it means we can write 0 is equal, R1 is 10 I1, minus 10 I1, minus R2 10 I2 and minus the equivalent resistance of these two is R3 times R3 4 is equal to R3 times R4 over R3 plus R4. So it's 30 times 15 over the sum of the two. It's 10 ohm. So here it's minus 10 I2. So it means second equation we can change it. 0 is equal to 10 I1 minus 20. There is a minus 20 I2. Okay, let's take away this one. So we have a system of two equations to resolve. We can change I with this. So we have I1 and I2 as unknowns, which we can resolve. So it's 580 is equal to 5 I1 plus I2 plus 60 I1. So we have 65 I1. That's right, 65 I1 plus 5 I2. Okay, so here we can calculate, is it right, this equation, 10, why is it 10 I1, it's 60, I check the first equation. 80 is equal to 5I plus 60 I1. Good. Okay, the second one is 0 is equal to R1 is 60, and here we have 10 and 10, so we have minus 28.2. So from here we can calculate I1 is equal to 20 I2 over 60. So it's I2 over 3. So I2 is 3 times I1. So if we replace now, this is first equation, second equation. So if we take this now, I2, and put it in this equation, we have 80 is equal to 65 I1 plus 5 I2, which is equal to 3 I1. So 65 I1 plus 15 I1. This is 80 I1 is equal to 80 I1 is equal to 1 amp. So we can calculate I2. I2 is 3 amp. And we can calculate now I, which is equal to I1 plus I2 is equal to 1 plus 3. It's equal to 5 amps. And that's it. We calculated all the currents. We can also calculate the current here if we, because I2 is 3 amp, the drop at the two resistors is 10 times 3, 30 volts. So it means that I3 is equal 1.34 over R3. This is 30 over 30. It's 1 amp, and I4 will be the difference, so it means it's 3 minus 1, so it's 2 amps. And that's it. We calculated all the currents, and thank you very much.